Yes, guys. So we are continuing with question number 6. Now, question number 6 is, as we have discussed about this in the fifth question, that we have to prove this theorem, verify the theorem. Okay, adjoint of A into A, the matrix, is equal to A into adjoint of A is equal to determinant of A into I, this value. So the same value we have proved in question number 5. Okay. This is a similar process, but in this case we have taken the square matrix of 3 by 3 order. Order is here 3 by 3, or you may say just of order 3. The square matrix of order 3, that means 3 by 3. 3 rows and 3 columns. Doesn't matter. This is the matrix here. For this, we have to find out now what is the adjoint of this first, then A into adjoint of A, or adjoint of A into A. We have to prove that this is equal to determinant of A into I. First, let me find out what is the determinant of A. This A here, okay, and then adjoint of A. So the right hand side can be calculated. This is determinant of A into I. Okay. For that, now let me rub this. This is the proper adjoint, but up to this point, this is after transposing this whole, you will find out this finally. So let me find the space here. Just to calculate these cofactors here, A11, A12, A13. After that, I will transpose it, then adjoint of A will be calculated. But before that, let me find out what is the determinant of A. So, determinant of A is equal to, we find out this as 1, 4, 5, let me solve it, 3, 2, 6, 0, 1, 0. How do we find out? With opening with the row number 1. This is 1 into 1, the value into this into this 1. Just leave this row and column, and whatever left over, the determinant value is to be here. 2 into 0 is 0, minus sign in between, 6 1 is 6, 6 here. Now in between, because this is 4 minus 1 raised over I plus j, so this is 1 plus 2 here, so this is a negative value, this is minus sign, 4 into, this is value of determinant. How do we find out the value of determinant? This are I have explained in determinant chapter, okay, determinant playlist. There, please, you can see that how determinant is calculated. This is with respect to either first row or first column or any row or any column. We can find out this value of determinant. Okay, just like minus, the value of minus we calculate what is the minus of 1. But in this case, in case of minus, we do not multiply by these numbers 1, 4, and 5. We will not multiply in case of minus or in case of cofactors. In case of cofactors, only the values with negative positive sign is calculated in case of minus. Okay, in case of cofactors, but in minus, no negative positive sign is good. But in this case, extra thing is, and we have to multiply by these numbers also. So cofactors into these numbers, this is the value of determinant. So cofactor of only first row or first column, or any row or any column, only that cofactors, and multiplying by those numbers also. For example, what is cofactor of 1? Cofactor of 1 will be multiplied by 1 also. This is this 1 into 0, 1, 6. Now this is minus 4 here. For minus 4, we have to take 3, 6, and this. So 3 into 0 is 0, minus sign. 0 into 6 is 0, this is also 0. A plus sign here, 5 into, this is positive. Why positive? Because minus 1 raised power 1 plus 3, this is third column, first row, 1 plus 3 means positive. Cofactors just like cofactors. Just multiply like number, and cofactor value is positive in this case. It will be 3 into 1 is 3, minus 0, because 2 into 0 is 0. This minor or cofactor we have to calculate. This is the total value of this determinant. Total value 0, 1 into minus 6 is minus. This is 0 here because 4 into 0 is 0. 5 3 is 15, plus 15. The value of this is 15 minus 6 is 9. plus 9. This is value of determinant here. And I, because here I is I3 of order 3, unit matrix or identity matrix of order 3 here, because this is A is here of order 3. I identity matrix or unit matrix will also be of the same order 3, 3 by 3 order. Finally, for the value of this determinant of A into I3, therefore determinant of A into I3 is equal to 9 in, this is matrix, unit matrix, this is 1 0 0 0 1 0 0 0 is the final value, or this is 9 0 0 0 9 0 0 0 9. So this is the right hand side there. This we have to calculate by finding out adjoint of A into A or A into adjoint of A after multiplication of adjoint of A into the matrix A. So that is the point. So let me find out what is the adjoint of A. So for that we have to find out the cofactors. The cofactors here. What are the cofactors? Let me check it. So here cofactors. Matrix of cofactors. All these values we have to calculate. After that, transpose is to be calculated by, adjoint of A will be calculated by transposing this whole values. Here A is 1 is equal to, this is positive value. Just side, let me take, this is plus minus 1 whole power 2 positive value into. Okay. This is A11 here. For A11, this is 2 into 0 is 0, minus 6 into 1 is 6. So this A11 value is, this is positive 1, this is minus 6 1. Okay, let me write here. A11 is minus 6. Now A12 is this is negative. Let me put minus sign because it's odd number here. 1 plus 2 is 3. Minus 1 is over 3 is negative. Minus 3. And then for this cofactor of 4 is 3 into 0 and 6 into 0, 0. It is 0 here. 0 1 0 0. This is 0. A12 equal to 0. Okay, we just calculated here. So, and A13 is equal to this positive because cofactor of 5 is, so it's cofactor of 5. This will be 3 into 1 is 3. This is positive value because minus 1. This is 1 plus 3, it is positive, plus 3 when you have 3 and minus 0, that means 3 1. Because A13 is equal to positive 3 plus 3. This is plus 3. Now let me rub this. These 3 cofactors of 3 numbers, 3 elements we have calculated. Now the second row. So A21, it is negative, but 2 plus 1 is 3, and minus 1 is over 3 is negative. Okay, now this. Leaving this row and this column, it will be 4 into 0 is 0, minus 5. 0 minus 5, 5 into 1 is 5. It will be minus minus plus, it is plus 5. A21 is equal to plus 5. Now A22 is this element 2. So cofactor of 2 is this leaving, this is 1 0 and 5 minus 0. So 0 means 0. It is 0 here. Negative plus or minus plus, this is positive 0 only. It is 0. A22 equal to 0. Why? Because 3 into 0 is 0. Sorry, this 1 into 0 0. 0 into 5 is 0. 0 1 0 0. Now then A23 this A23 6 cofactor of 6 is negative because 2 plus 3 is 5 minus 1 is 4 5 is a odd number, it will be negative here. Then of 6 means this leaving and this leave it, this 1 into 1 is 1, minus 0 plus 4 into 0 is, it is minus 1 only, because minus 1 into 1 is minus 1. This 8 to 3 is equal to minus 1. Okay, these three cofactors of these three elements have been calculated. For the last row, A31 of 0. What is cofactor of 0? A31 is positive value, because 3 plus 1 4, minus 1 is 4 is positive value, it is plus 4 only, I mean plus sign only. Of 0 is this 4 6 is 24 minus 510, this is 14 only positive value, it is plus 14, well 24 minus 10 is 14, so this is A31 is plus 14. Okay, now next cofactor of next element, that is A32 cofactor of A32 means of 1. Say this one, this number of 1, for 1 leave this is 6. Okay, this is negative because minus 1 is 4, 5 is negative, then it will be of this 1 here. Yeah, A32 is this 1. So we have left this and this, so this is 6 1 is 6 minus 15. So 6 minus 15 is minus 9, minus 9 into minus is plus 9 here. So A32 to be right here, A32 is equal to plus 9. Now A33 last. What is A33? Cofactors of A33 of 0 here, of this 0. This is 1 into 2. So what is this is positive here, plus sign. The bracket will be 2 and 2, 2 minus 12, that means minus 10. Okay, because 2 and 2 minus 12, 2 minus 12 is minus 10. Minus 10 here. A33 equal to minus 10. So therefore, adjoint of A transposing, now this, first let me write this whole value. After that I'll transpose it, so adjoint of A will be calculated. A11 is minus 6, A12 is 0, A13 is 3, A13 3, A21 is 5, A22 is 0, A23 is minus 1, A31 is 14 here. Okay, and then A32 is 9 positive, this is minus 10, A33 is minus 10. This is of transpose of this, transposing this now. Transpose of this, therefore adjoint of A is equal to, now this is minus 6 0 3, putting making this row as column, first row as first column, second row as second column. This is 5 0 minus 4, then the last row is 14 9 is minus 10 here. Because this is adjoint of A. Now let us find A into adjoint of A, left hand side. Okay, so this is the adjoint of A we have calculated. Final value, this is adjoint of A. Okay, therefore A into adjoint of A, let me write in bracket. A into adjoint of A, let me write A is this is 1 4 5 3 2 6 0 1 0 into adjoint of A is this, we have to keep as it is. This is nothing but minus 6 5 14 5 14. Okay, then 0 0 and 9, 3 minus 1 and minus 10. this is the final value. Okay. Therefore, now let me, okay, this adjoint we have to remember. Or let me write here what is the adjoint. Adjoint A equal to minus 6, 5, 40, and then 0, 0, 9, 3, minus 1, and minus 10. So this is adjoint of A in this case. A is this, adjoint of A is that. Now let me rub this. Find the value of the multiplication of A into adjoint of A. Let me check whether the same value comes out as this 9 into this. Let me check. Okay, so multiplying first row, first column, then second column, then third column. 3 elements will be there. What is the element? 1 into minus 6 is minus 6. 4 into 0 is 0 plus 0. 5 into 3 is plus 15. Okay, this 15 minus 6 is 9, undoubtedly. In values obtained. Then first row, second column, second element here. This is 1 into 5 is 5. 4 into 0 is 0. 5 into minus 1 is minus 5 is 0. Alright, obtained. Then third element. For third element, first row, third column, 1 into 14 is plus 14. 4 into 9 is plus 36. 5 into minus 10 is minus 40. Sorry, minus 50, I'm sorry. 5 into minus 10 is 50, which is 0. Because 14 plus 36 is plus 50. This is minus 50, so it is 0. 9, 0, 0. Got the point? This is 9, 0, 0. Same value is obtained. Okay. Then second row, first column, 3 into minus 6 is minus 18. 2 into 0 is plus 0. 6 into 3 is plus 18. It's plus 18 minus 18, 0. Alright. Then second row, for second column, 5 into 3 is 15. 3 into 5. 2 into 0 is 0. 6 into minus 1 is minus 6. It is 9 here. 15 minus 6 is 9. Alright. Then second row, third column, 3 into 14 is 43. Sorry, 42. Okay. 3 into 14, 43 or 42. Then 2 into 9 is plus 18. 6 into minus 10 is minus 60. 42 and 18 is 60 plus, and minus 60 is 0. No doubt. Now third row is this 0 into minus 6 plus third row and first column give us first element. It is minus 6 into 0 is 0. 1 into 0 is 0. And then 0 into 3 is also 0. 0, 0, 0. It is 0. But 0 into 6, 1 into 0, 0 into 3, 0. All 0 values is 0. And third row, second column, 0 into 5 is 0. 1 into 0 is 0. 0 into minus 1 is 0. All that is also 0. Then third row, third column of this element, 0 into 14 is 0. 1 into 9 is plus 9. 0 into minus 10 is 0. which is plus 9. Very good. So same value is obtained. This is 9 here. Between minus 6 is plus 9, 0. This is also 0 because 14 plus 36, 50, 50 minus 50, 0. 18 minus 18 plus 18, 0. 15 minus 6 is 9. 42 plus 18 is 60 minus 60, 0. It is 0, plus 0 plus 0, 0, it is 0, and it is 9 only. Same value, 9 if I take common, it will be then 1, 0, 0, 0, 1, 0, 0, 0, 1. Identity matrix into determinant value A, because A is determinant value is 9. So 9 into this same value, right hand side is obtained. Now, if I multiply, okay, this is the first thing we have put. same value is obtained. Now if I write this is A into adjoint of A, now we have to write adjoint of A into A. That will also be the same thing. Let me just read. Second case is we are verifying this theorem. Now this is adjoint of A into A. That means first adjoint value is this minus 6, 5, 14, 0, 0, 9 is 3, minus 1 and minus 10 into A. A is just 1, 4, 5, 3, 2, 6, 0, 1, 0. Already multiply. First row, first column, then second column, then third column, multiply, getting the elements here. Minus 6 into 1 is minus 6. 5 into 3 is plus 15. 14 into 0 is plus 0. Okay, 14 into 0, 0. It is 0. It's 15 minus 6 is 9. And out in value of it. Now first row, second column, minus 6 into 4 is minus 24. 5 into 2 is plus 10. 14 into 1 is plus 14. 24 minus 24, 0. Okay, this is also being proved. Values are coming in the same way. Now, first row, third column, minus 6 into 5 is minus 13. 5 into 6 is plus 13. 14 into 0 is 0, plus 0. Minus 30 plus 30 is same values of it. Okay, now, second row, first column, 0 into 1, 0. 0 into 3, 0. 9 into 0 is 0, that is 0 here. Then second row, second column, 0 into 4, 0. 0 into 2 is 0. 9 into 1 is 9, plus 9. It is 9 in between. Diagonal elements are 9 and 9. Okay. It is 9 here. Then second row, third column, 0 into 5 is 0. 0 into 6 is 0. 9 into 0 is 0. Alright, it is 0. Now third row, first column, 3 into 1, 3. Minus 1 into 3 is minus 3. Minus 10 into 0 is 0. It is also 3 minus 3 0. Okay. Then third row, second column, 3 into 4 is 12. Then minus 1 into 2 is minus 2. Minus 10 into 1 is minus 10. Minus 12 plus 12, 0. Alright. Then third row, third column, 3 into 5 plus 15. Minus 1 into 6 is minus 6. Minus 10 into 0 is minus 0 plus 0. Minus 10 into 0 is 0. Now this is 9. Same value is obtained. What we see here, 15 minus 6 is 9. Then is minus 24 plus 24, 0. Minus 30 plus 30, 0. Same value, 0. 0 plus 0 plus 0 is 0. 0 plus 9 is 0. 9 is 0, 0, 0, 0. It is 0 here. 3 minus 3 is 0. 12 minus 12 is 0. 15 minus 6 is 9. What we see here, 9 into, this is identity matrix. Identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so the same identity matrix into determinant value of A multiplied. Determinant value of A into I, identity matrix I3. So this is the proof of question number 6 here. We have done question number 6 now. Hence the theorem is verified, whatever the theorem of based on adjoint of matrices given is proved. Okay. With this illustration, this question number, we have proved it that yes, this is true. Now let us take next question. Now question number 7, will it say? Let me check it. So question number 7 is of what kind? Let me see. This is question number 7 here. Seventh question says, define adjoint of a square matrix. So I've defined this in the question in the beginning, okay, but let me again define. Define adjoint of a square matrix and verify the properties of it with an example. So, the property of it, adjoint of a matrix, is simple. We have just talked about that adjoint of A into adjoint of A equal to adjoint of A into A equal to determinant of A into I. So that we have proved. But what are the properties that define adjoint? So let me define it. Definition of adjoint of a matrix, or adjoint of a matrix. Adjoint of a matrix. What is the this is the transpose. Let me define it. A transpose or transpose matrix of transpose of the transpose matrix. Let me take a transpose matrix of a matrix of cofactors, of a matrix of cofactors. A transpose matrix of a matrix of cofactors is known as adjoint of that matrix. Adjoint of a given matrix. Let me take what is the transpose of the matrix of cofactors. Or cofactors matrix. Transpose of the matrix of cofactors. And what is a cofactor? We have that defined. Okay. And cofactor is, so what is a cofactor? So as I have defined, let A is equal to, I have taken A11, A12. Let me take it is A21, A22. Only 2 by 2. This is square matrix here. So a square matrix, a transpose matrix of a matrix of cofactors, or square matrix of a cofactors of a square matrix here, of a square matrix of cofactors is known as adjoint of a given matrix, given square matrix. It is a square matrix here, 2 by 2 matrix. Now, what is adjoint cofactors matrix? So matrix of cofactors. So matrix of cofactors of A. Let me represent this as A capital A11. In this case, we have taken only 2 by 2 matrix. So any matrix of order 3, order 4, order 5, or larger number of orders can be taken. But we have taken here simple one of order 2. This is 2 by 2 order or 2 only. You can say order 2. Okay, 2 rows and 2 columns. This is square matrix here. And this is A21, A2. This is the matrix of cofactors. But transpose of this. Therefore, transpose of matrix of cofactors of a square matrix of a square matrix of cofactors of its cofactors. So in this case, we have to just transpose this. Therefore, is given as, what is the adjoint in this case? Adjoint of A will be given as, in this case it is A11. This A1 row will become column. It is A12. This is A21, A22. So this is the adjoint matrix. Adjoint of a given matrix. So first we have to find out the cofactors. Cofactors, as I find out what is cofactor. Cofactor of an element of a matrix, of a square matrix or of a matrix is given by minus 1 raised to power I plus j into minor of that element Okay, so minor we have defined that it's a determinant value after leaving the row and column in which that element is lying. So minor of an element is given by leaving that or removing that row and column or not considering that row and column. Then whatever is left over in that matrix, we find out determinant of that. The determinant value is known as minor. Okay, so minor is without any sign, but this minus 1 whole power I plus j is giving us a symbol, a sign, negative or positive. Give us negative or positive. If the sum I plus j is even number, it is positive. If it is odd number, then it is negative, as we have just calculated. This is how we find out adjoint of a matrix. Okay. We have taken this illustration. Now I have just transposed it. So this is transpose of the matrix of cofactors. Now these cofactors are calculated as what is A11 here. For example, in this A11, if I have to find out A11, that is minus 1 raised to power 1 plus 1 into a minor of this. The minor of this is, but in this case it is A2 because this row and this column is left with A22. In this case it is A2. Whatever the value of A22 is there, that sorry, not A22. In this case, this one, the smaller value. I'm sorry. This is A22 here. The smaller element, this value. For this row and this column left over, whatever left. In this case, it is square matrix. Only this element is left. This element is minor value. This value will be here. You have to put. This is cofactor of A1. Similarly, A12, if I have to calculate of A12, it will be 1 plus 2 negative value minus 1 raised to power 1 plus 2. 1 plus 2 into. Now this row, sorry, this column and this row, that's not this is A21. In this case it is A21. Similarly A21 is also negative because it's negative sign. Minus 1 raised to power 1, 2 plus 1 into this left over this, so it is A1 into A1. Last A22. What is of A22? Cofactor A22 is equal to minus 1 raised to power 4 plus 2 into A22.